This is a video for OCR Pure Core Mathematics, Sequences and Series 2, Maclaurin series, 2.4, Maclaurin series of composite functions. We've seen the standard Maclaurin series below in a previous video, and these can be combined together to find polynomial expansions of more difficult composite functions. So let's think about this example for a minute. Find the expansion up to the term in x cubed for e to the x cos 2x. Well, one way we could establish the Maclaurin series formula for this is we could set up a function fx equal to e to the x cos 2x and then work out sufficient derivatives to substitute into the general Maclaurin series formula. However, this thing here is a product, and we would be differentiating that 3, 4, 5 times, and each time we would have to differentiate it as a product, and each time it would be getting more and more complicated. So it would help if we could find a quicker way, and generally that is quicker if we use the standard expansions. So let's have a look at this in a bit more detail. Terms up to x cubed for this thing here, and we've got e to the x and we've got cos x. So let's see how that works out. I want e to the x cos 2x. Well, the expansion for e to the x is just going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus however many other terms I think I need. However, I'm only going up to x cubed, so anything with x to the 4 and above won't be needed. And if I multiply that by cos 2x, well, cos x is this thing, cos 2x will be this with the x's replaced by a 2x, so I'll get 1 minus 2x all squared over 2 factorial plus, well, the next term would be 2x to the power 4, and I don't want anything as high as x to the power 4, so I'm just going to leave it there. So now let's just simplify those a little bit before we use them. So I'm going to get 1 plus x squared over 2 plus x cubed over 6. And I know there are some other bits, but I'm not going to be using them. And from this I'm going to get 1 minus 4x squared over 2 is just 2x squared. And again, there are other bits, but we're not going to be concerned by them. So if I do 1 times all of these, I'm going to get 1 minus 2x squared. And then I'm going to get plus x times all of those things. And then x squared times all of those things, x squared over 2 in fact times all of those things, and the x cubed over 6 times all of those. And I don't need to consider anything larger in that bracket there. Now let's just pull these out. I've got 1 minus 2x squared plus x minus 2x cubed, and that's okay because I want to go as high as x cubed, plus x squared over 2, and then the next one will be x to the power 4, so I can ignore that, and then I've just got plus x cubed over 6. And so that simplifies to 1. If I look for the x's, I've just got a plus x. Let's deal with that bit and that bit. And then x squared, so I've got a half x squared and a minus 2x squared, so that's minus 3 over 2 x squared, that's dealt with those. And finally I've got a minus 2x cubed plus 1/6 of x cubed, so that's going to be minus 11 over 6 x cubed. And so that's my e to the x cos 2x up to x cubed. And there that is written up neatly for you. You can see here the Maclaurin series we've taken just up to x cubed and below first of all. That's then been tidied up here. And then looking at each of the powers of x and just collecting them together gives me this as the final result up to x cubed. That was the last video in this sequence, Sequences and Series 2, Maclaurin series.